Right. Hello, everyone. My name is Renazad, and today's presentation follows on with our series of presentations on mechanical engineering in the process industry. Today we have speakers from water and wastewater and food to tell you about their respective industries. As always, just please type your questions in the Ask a Question box and we'll address them at the end. We have CPD certificates available for those attending today, so please get in touch with Murat Islam, whose email will be on the last slide. And yeah, let me hand over now to the presenters to introduce themselves.
Thank you for that. I'm Pamela Robinson. I work as a principal mechanical engineer for Atkins in the water and wastewater industry. I've been involved in the wastewater industry for above 18 years now, and I'm a member of the IMechE Water and Wastewater TAC Committee. Thank you.
Hi, my name's Robert Chin, and similar to Pam as well, mechanical engineer, and I work with Atkins in the water and wastewater team. Been in the industry for about 12 years now.
Morning everyone, my name's Abigail Pinkard, and I work with Kerry as a project manager in the Netherlands.
Hello everyone, I'm Penny and I work as a project engineer at Coolmill Systems, which is a rice processing company.
Lovely. Thanks, everyone. I'll now pass over to Pam to get us started.
Thank you. So just an introduction to the water and wastewater industry. If you've got any questions, if you can just type those into the chat and we shall answer them at the end. If you can let us know if it's who it's addressed to, that would be beneficial as well. There we go. Just in this next 20 minutes, we're just going to give you a brief introduction, myself and Robert, on the water and wastewater industry, where we as mechanical engineers help, which industries we work with, a basic introduction to the treatment process within your clean and wastewater treatment works, what is wholesome water, a little pause for thought, a little sustainability thought for yourself. Then Rob will take over with the environmental management and looking at energy and efficiencies within our water and wastewater industry, and then we'll just close with a summary. So on with the industries. We are mechanical engineers within water and wastewater industries, so we can obviously work with the water companies, which I'm sure is fairly obvious in the water and the wastewater sector. However, we do also work with the Environment Agency, looking after their pumping stations, upgrading their pumping stations for flooding events and the like. We also work with the housing development industries. You have surface pumping stations and network pumping stations that need to be incorporated into the existing infrastructure that we have. We also work with the railway, because likewise there's drainage issues associated with railway that needs to be either incorporated or separated from our existing infrastructure. We work in the nuclear sector as well. Again, many pumping stations and some nuclear sites have their very own wastewater treatment works on site that they need to look after and manage, and we work with that industry. We've also been known to work with water parks. There's a large park being built over in Qatar, and we've been involved in the design of that. All the water needs to get pumped round and it needs to be clean. So we do definitely get involved in that side of things on the mechanical engineering front. And highways, to mention another one. All your surface water runoff from your motorways, from your road structures, needs to go somewhere, and we will be involved in that as mechanical engineers. Just to name just a few industries, I'm sure there's a few more on there. We've also got a picture on there of the Canals Trust. We work with those industries too. We get everywhere, basically. Just a basic clean water treatment process that you could have. This particular example shows an extraction from either a river or a reservoir. It's then pumped on. There's some sedimentation. Obviously, you can't drink straight out of a river or a reservoir, a raw water reservoir that is. Then some filtration, some disinfectant in there, some chlorine added, It's then stored so that it can then either be pumped or gravity fed to our homes and businesses, so it comes out of the taps in a wholesome form, so it's safe to drink and it's at the right pressure. We could have extractions straight from boreholes that typically requires less treatment and could just need disinfectant, and then it's safe for us to be able to drink. We can also extract from the sea. However, this is really quite not very cost effective. It needs a high power demand and it's quite expensive from that purposes. So sea isn't the obvious choice for clean water treatment. Onto perhaps a typical wastewater treatment works. This is pumped or gravity inlet coming in from the left. We've then got some upfront screening to take out the larger debris. We've got some grit removal in there as well to take out the grit. What's then left goes through to primary sedimentation, and we basically take off two forms. We take off the effluent, the liquid off the top, and the sludge is removed from the bottom. That liquid off the top, the effluent, then goes on to secondary treatment, which could be trickling filters, it could be aeration, it could be any number of treatment possibilities, depending on what the influence is and what it needs to be. We then could have some tertiary treatment, secondary settlement rather, and then some tertiary treatment as a final polisher. All the sludge that comes off the sedimentation aspects of the treatment can then be used, and this is probably slightly more interesting. You can use the sludge and basically you can extract the gas off the sludges. The gas can be used to be cleaned up and fed back into our gas network. The gas can also be used to fire boilers to provide electricity back into the grid. The sludges are then dewatered and these are dried and they can be sent back to land for obviously nourishment for land. So it's slightly more interesting, you could say, on the sludge side of things. Also within our clean and wastewater treatment processes, not all the treatment processes are the same. It can vary depending on what comes in and what needs to go out. There are network pumping stations between our houses, certainly on the clean water side, between the works and our houses and industries. We need pumping stations to get it to the far end of the network. On the return, the waste that comes into our wastewater treatment works needs to be pumped to our works. They can't always be gravity fed. This AMP in particular, the clean and wastewater work in 5-year work periods, and in this AMP we are heavily focused on removing phosphorus from the sewage effluent, and I've shown a picture on the side, the left, which is a chemical dosing set which we've designed within Yorkshire Water for removing the phosphorus out of our effluent so that we don't pollute the rivers or send as much phosphorus, shall we say, to the rivers, which is just an add-on side stream process that engineers are required. Engineers are required at every stage of site. We need to be there at the feasibility, we need to be there at the outline, we need to be there at the detail, as it's being built, being commissioned, then when it's monitored, it needs to be maintained, it needs to be optimised, and then finally it needs to be decommissioned. Engineers are required at every stage. And we can't just work as mechanical engineers either. We need to be involved in a team. So we have the process engineers to help with the process side of things. We have the mechanical engineers, which are ourselves, the electrical help to power everything, and then the ICA help with all the instrumentation to make sure it runs correctly. And there's also a new digital world that we're trying to embrace, and embracing digital twins of our works. And one obvious missing one is a civil engineer as well. We all need civil engineers as well to help put the concrete there and the tanks there. Wholesome water. Well, you can't just assume that because 75% of the water is safe to drink, only 3% we're able to use fresh water, and only 5% of this is available. The rest is frozen, and we can't gain access to it. So even though our planet is quite blue, there's very little available that's safe to drink. On a daily basis, we use 10 billion tonnes of fresh water worldwide every day, which is an awful lot. In the UK, we use an average of 142 litres per day, and this isn't including all the products that we use, such as food, which is coming on later, the clothes that we wear. All those use water as well. We really need to be thinking about how much water we actually use. Can we reduce the amount of water? Because it's not an infinite supply. It could run out, and there is theory to say that it possibly would run out, will run out. My pause for thought on this: bottled versus tap. Tap water, I would strongly recommend, is better than bottled water. It's fresher, it's more heavily regulated, it's much cheaper, there's less plastic. They're my thoughts. And another thought for you to take away today is tap water. Do we really use it in the most optimum place? Should we really be using our clean tap water to flush our toilets and water our gardens? Are there other options available that we could consider to reduce that 142 litres per day down further? It's just my pause for thought to get you thinking on this Thursday lunchtime. And now over to Rob. Thank you.
Hi everyone, thanks Pam. So just following from what Pam's spoken about, I just wanted to highlight some of the challenges, the issues and considerations that we face in the water industry. One of the main things that's been at the forefront quite recently has been sewer discharges into rivers causing pollution, untreated sewage being put out, which water companies haven't been able to capture. And so that's an area that needs looking at to be more closely monitored and alarms raised and to try and stop those kind of events. Another big challenge as engineers and as a planet we face is climate change, and we had the COP26 up in Glasgow last year, where the water industry was present, and you can see one of the statements there, probably blindingly obvious, but I think it needs to be reiterated, is like water and nature is inextricably linked. And in the water industry, drought has been a big concern. I mean, although the UK, we do complain it rains a lot, that we do experience, or we are experiencing, longer periods of drought, and Pam touched on that a little bit earlier. And I mean, there was quite a close call with South Africa a couple of years ago, where they almost ran out of water. But then also on the flip side, we're seeing a lot more heavy flooding and flash floods compared to what we used to. So the once in 50-year events are coming a lot more frequently. So challenges for engineers are in terms of drought and flooding mitigation. So what are the other things, some of the other considerations, just aside from the main engineering aspects of what we do, is also in terms of land management. And one of the first things we usually query is, do we actually need to build that structure? Do we need to put new concrete underground? Do we need to dig up things? Do we need to, can other systems and processes be optimized or reused to save that investment and that disruption? And that leads into the next couple of considerations as well, in terms of conservation and ecology, what we as engineers need to take into account. There's not always apparent. A lot of companies now are looking at, especially water companies, they have a lot of land and they're looking into conservation, increasing biodiversity, not just in terms of insects and plants, but also insects and wildlife, but also in plants as well. And ecology, where we're trying to minimise disruption, protect endangered species such as great crested newts, bats and eels, and then catchment management as well is an area that we look at in terms of how we get the water from our original raw source. So a lot of water from rivers and reservoirs and so forth contain a lot of pesticides or fertilizers from surface runoff from farms and businesses and so forth. So it's all about working upstream with those users to try and minimize the amount of chemicals and so forth they put into their fields. And then, so the picture on the side there is actually a reed bed. So that's another form of treatment that doesn't rely on pumps and mechanical and other man-made forms. It's plants essentially removing the organic material from the water before it can go back into a watercourse, and also that allows flora and fauna to flourish, birds, nesting species, bugs, and all the other animals that eat the bugs and so forth, that to live and grow in those reeds. And also from the point the water is abstracted from rivers and reservoirs right to the point that it's cleaned up and discharged back into the environment. It's a heavily regulated affair. And then just there's been a big drive to net zero and sustainability as well. So on the back of that, the water industry uses about 3% of the total energy produced in the UK, and generates about 1% of CO2. So that's quite, if you imagine the amount of energy that the UK produces, that's quite a big figure. So anything we can do in terms of reducing that is definitely beneficial. So in the next few slides, I'm just going to talk about quickly some of the technology that we use to try and alternative sources of energy that we try to reduce that figure. So obviously, water companies have a lot of water, and that's one of their major resources, of course. So where possible in reservoirs, they try and install hydroelectric turbines to generate power from the water. That one is a picture of Derwent Reservoir in the northeast, and that was the Kaplan turbine that they installed there. The next stuff is advanced anaerobic digestion. So Pam talked about digesting sewage sludges a bit earlier, and essentially it's power generated from bacteria, and so it's power from human waste. So it's whatever you flush down the toilet is digested by microbes and generates methane, which those two white golf balls you can see in the forefront in the top left picture, and the one in the bottom right picture. So that's where the gas is stored. So then, so it's power from poo essentially, and I'll just put a little anecdote there. So it's not to be poo-pooed. Apologies for the bad joke. Also, the next one is harnessing wind power. So what people usually associate with that is big wind turbines out to sea and other forms where you see the big mast and the windmill. But what we've got here as well is an innovative idea of using aerators, wind-powered aerators, as part of the treatment process. So the left-hand picture, the far left picture, you can see you can kind of see the turbines, the vanes that capture the wind, and on the far right is the actual aerator that dips into the water. And the top picture at the back, you can kind of see the scale of it. Those are the lagoons, the aeration lagoons, which contain the effluent and the bacteria that need feeding with the oxygen generated by the aerators. And the bottom middle picture you can see there is a bit of a closer up picture of the arrangement there. And then finally, typical, a very common one, solar power as well. So solar power with solar panels that they're looking at being installed all over various offices and businesses and the homes. So on the left-hand side, it's proved quite a useful alternative to power some CCTV cameras to look at outfalls where power to the site is not as easily available as some others, and it would be quite an investment to get a new power supply out to that remote location. So they've put that on a solar cell to drive the camera. The middle picture, a lot of the processes contain large buildings on treatment works and sites, so it makes sense to put solar panels on the building roofs like we do in our homes. So that's a source of energy. And then also on the construction side, on the bottom right, there's a little solar generator, so that helps reduce the amount of electricity from the grid and also from diesel generators that typical construction site cabins might utilize. So aside from the actual energy side, some of the efficiencies I just want to go through that we look at to try and improve and help the cause to drive to net zero and sustainability is looking at life cycle costing, how much over the whole life cycle of the equipment, of the product, and how that affects our decisions, carbon embodiment and sustainability, we've got optimization of processes, equipment selection, such as more efficient pumps on the left-hand side. In the pie chart, you can see a typical breakdown of how much over the life cycle of how much a pump costs. So the very rough figures. So the actual cost of the pump is 10% of the overall life cycle cost, but you can see energy a massive 40% there. So any of those alternatives that we looked at previously, or choosing a more efficient product, will help reduce that energy consumption and ultimately the energy bill and usage. Chemicals as well. How do we reduce chemicals? Can we optimize processes to use less chemicals? Obviously, less chemicals means less impact to the environment and what we put out there and things that we have to use. Automation and remote operation. If assets can be monitored remotely, then that avoids having to send out someone in a van to remote locations and back and forth, and a lot more in terms of efficiency there. An interesting one is ochre reprocessing, a mineral reprocessing. So Pam talked about earlier about removing phosphorus from wastewater. So there's been schemes looking at ochre in terms of mine water, the iron from mine water, trying to process that and use that iron as part of the treatment, as one of the chemicals in the treatment process, rather than having to buy additional chemicals. Also, phosphorus, trying to remove the phosphorus from wastewater and using that as a recovered byproduct for sale. And Pam touched on digital twins as well, so replicating physical assets in the digital environment allows us to model and predict how things will operate and what scenarios can potentially occur in the future to try and mitigate them before they actually occur, without having actually to build anything or find out the hard way. And then also in terms of just a general recycling point of view, Pam mentioned as well, just the fertilizer, the byproducts from anaerobic digestion can be used as fertilizer to help soil condition and instead of just putting to landfill. So the last bit I just wanted to capture, and it did look a bit better on the contrast did look a bit better when I did it on my computer, but I hope you can read that okay. It's just a bit of a summary. So the water industry is a very vital industry for everyday life, and we work across multiple sectors. And for the takeaway thought Pam had, it was think of water as a foodstuff as well, and it's a precious resource. engineers, we work to improve the environment and try and minimise the impact that we have on our surroundings, and then we do this with working via a number of disciplines, from civil engineers to process engineers and everything in between. And we use a lot of new technology, renewable energy, to try and reduce our demand on the grid. And it's a very challenging, mature industry. We've got a lot of challenges in terms of climate change, but also a lot of the industry is built already, so it's a lot doing to retrofit and optimize existing assets. And that brings me to the end of the water and wastewater industry introduction, and I'll pass on to Abby.
Thanks so much, Robert. So yeah, I'm going to be kicking off the food industry half of this webinar. And yeah, as the slide says, once again, my name is Abigail Pinkard. I work with a company called Kerry as a project manager in the Netherlands. But as an introduction, first slide, I thought I'd kick off going into what does Kerry do. So Kerry is the global leader in the development of taste and nutrition solutions for the food, beverage and pharmaceutical markets. We've got over 148 manufacturing locations with over 18,000 products and 22,000 employees. But for a lot of you, you may not have heard of our name. So in the food industry, you'll be very used to hearing brand names. So you go into a supermarket and you buy branded food. What Kerry does is a lot of the kind of core ingredients and flavorings and different additions that go into those branded products that you see. So although you may not know Kerry as a company name, you probably consume something that we've had some part in along the supply chain every day. So that last point at the bottom there, so Zwijndrecht is the site in the Netherlands where I work, and we produce emulsifiers. So the photo on the right there shows you water and oil, which if you think back to your primary school science lessons, you may be familiar with being two solutions that don't combine. So they sit on top of each other because they have different densities. And what an emulsifier does is that it suspends one of those liquids in the other. So then instead of having water and oil, you then have a solution where they're both combined and kind of integrated. So we make emulsifiers. Those things go into all sorts of products. So you can think about your bakery items, your ice creams, your chocolates. Specifically, something from our site that we go into is a Magnum. So one of those ice cream bars with the chocolate on the outside. Our emulsifier helps control the thickness of that final chocolate layer so that it gives you that crunch that you want without breaking your teeth at the same time. So now that you've got a bit of an idea of what Kerry does, the question of how did I get here? So for all of the young members on this call or potential professionals looking to change industries, this is just a little bit of a step-by-step. So how did I get into the food industry and working for Kerry? First up on the top left there, I've put interested. So I was interested in the food industry. I'm a bit of a foodie myself. I like to cook, I like to bake, and my kind of guilty pleasure at school was watching the TV show How It's Made, because I was just fascinated seeing the kind of machinery that produced 30,000 ice cream cones every second, or how these different things were packaged and just how vast and quickly these things were happening, and kind of looking at how they problem solved and made sure that this process was just in a kind of smooth, continuous flow. So yeah, once it first kind of hooked my interest, then I had to get qualified. So I went to the University of Exeter and did a degree in mechanical engineering. I'd personally recommend that as an IMechE member, but also just the breadth of which the doors are open to you as a mechanical engineer are really quite inspiring. So then after I was qualified, to get specifically into the industry, I had to be assessed. So for me and the process with Kerry, which is very similar to a lot of other kind of graduate schemes if you're looking to enter that way, involve written application. Then after that, there's some online assessments. So those can be things like your verbal reasoning, those kind of different space assessments, all online. And then after I passed those, I was invited to a kind of assessment in person. So with a couple other candidates, we went through a day of different exercises, different kind of team tests to see how you work together, to see how you problem solve. And then following that assessment, I was offered a role in the Netherlands. And personally, I have a kind of international upbringing abroad, so that was definitely an exciting challenge for me. which on the far bottom right there you can see ended in a yes, and I moved to Zwijndrecht, which is an incredible Scrabble score if they ever allowed place locations. So up next then, what do I actually do? So once I got to the Netherlands, I was part of a 2-year graduate program. So that came straight out of university. And specifically in the Zwijndrecht location, I was involved in a couple of different projects, which I would highly recommend if you're just joining the industry. Try to keep your experience broad. Take every opportunity as one in which you can learn. So up there on that first point, I had the spray cool tower optimization, which might be a bunch of unfamiliar words, but for us in emulsifiers, they are a liquid product, but also some of our customers would prefer it more in a solid form. So a spray cool tower, what it does is it sprays that hot liquid from the top, and then you have it's kind of 3 stories tall. These are huge kind of chambers in which that product is sprayed out at high pressure, and then it cools into lots of tiny little spheres. So by the end of it, you kind of have a bag of sugar or sand, so lots of solid little spheres. And as part of that, I was involved in a project where we were actually changing the nozzle part from one vendor to another. So I had to go through the different recipes we had on site to make sure, almost Goldilocks style, that those final particles weren't too big, they weren't too small, they weren't too hot, they weren't too cold. And that was an incredible kind of interdepartmental collaboration where I was working with the maintenance team, I was working with the operators in production, also with R&D, also our quality department, to make sure that everybody was happy with, as we were making these changes, that the product was what it was supposed to be, and also the operators who were kind of executing this project were also happy too. Besides that, I did some continuous improvement of our spare parts warehouse. So that was kind of more focused with the maintenance department and making sure, because we have 3 different factories on site which have numerous pumps and valves and indicators and sensors that need to be maintained, that all the parts, when they go out for those maintenance jobs, are easy to find and can also aid in stock checking. So the Kanban system, most of you I'm sure is probably aware of, but using barcodes to make sure that that information is captured fairly and is, just aiding the efficiency of that whole process. And then finally, on that last point there, I've mentioned a couple different technical documents that I worked with. And if any of you were in the last webinar, John Bartlett did an incredible overview of the different design documents, the key kind of design documents that are involved in a project. So P&IDs stands for Piping and Instrumentation Diagrams. Excuse me. Also things like process flow diagrams or your floor plans, isometric diagrams, MTOs, which are material takeoff lists. All of these different documents are crucial in the industry. And actually, the more literacy you have with those, you gain them over the time using them, of course, but then when you go into a factory, you know that that documentation in front of you can help you to kind of view that process more fluidly and understand which part connects to another. Because sometimes when you walk into a factory, you see pipes everywhere and you don't know what's in which one and which one they're going, but that's where that documentation really helps you. So as a graduate, I did a lot of kind of administrative work, making sure that they were up to date, using a lot of AutoCAD to help kind of edit or update those. And then finally now, so after my graduate program, I've involved more in kind of the project work side of things. So a couple different photos there show what can be involved in a normal day when I'm coordinating different contractors. So on the left there, you've got probably, I can't remember now, probably DN100 diameter pipe being lifted up 4 stories to the top floor of our factory. So it's obviously making sure that those activities are happening in a safe way. On the right-hand side there, you have when we had some snow on site, and then actually in the resulting days, we had some ice on the ground. So everything that's kind of involved in doing a project is kind of, your eyes are open to actually so many different influences in making sure that you achieve your project goals. I should also classify that actually after the graduate program, I moved on to a more installation project. So looking at the future of our factory, we wanted some more reactors and cool bands installed. So that's kind of equipment that all needs the piping connections to our tank parks. So yeah, I've been involved a lot more on the kind of site coordination and project management work to make sure that timelines are stick to, and that my field activities are being monitored for quality and for if they're following the kind of attained time management roles. Finally, things like punch and snag lists. So they might have installed the pipe, but let's make sure we do a hydro test and make sure that that weld is up to quality. If it has a leak, then let's fix it. Or if a valve is missing where it should be, where did that valve go? Let's find it and make sure it's installed. And then my final point on this slide is documentation again. So similar to the grad program, we continue again making sure that all of that documentation is in check, and also signing out a project, making sure you have all that legally required documentation to make sure you close out successfully. So that's a very quick, broad overview of what I do, but happy to take questions at a later time. And for now, I will pass on to Penny.
Hello, so I'm Penny Morton from Coolmill, and just so you know, there's been a little bit of a mix-up with my slides, so I might just pass over some, just so you know. But yeah, just a bit of background on me. So I'm 24, grew up in Scotland with my 4 younger siblings, and today I'm going to give you a little bit of a background on my journey into becoming a rice engineer, and then tell you more about what I do on a day-to-day basis. So at university, I studied product design engineering, which is a combination of mechanical engineering at the Glasgow University, and then that's combined with design challenges that we complete at the Glasgow School of Art. So here are some of the projects I completed during my course, just to give you a bit of an idea. I took reclaimed circuit boards and made them into decorative cacti, which were then sold in a shop. I was quite passionate about exposing the beautiful engineering that's hidden away in our laptops and kind of giving them a second life. I then designed and developed a sustainable and interactive children's toy, which was made from cork that used lasers to create music. And through that, we had to make accurate engineering drawings, so our products were ready for manufacture. And then following that, in groups, we made robots. Has someone got their thingy on? Okay, so sorry. In groups, we made robots that we then battled against each other. And then also for my master's project, I don't know if this slide's going to load, but for my master's project, I designed an aquapod, which was a modern alternative to a waiting room aquarium. And this kinetic aquarium system was populated by biomimetic magnetic fish, which was designed to improve the physical and mental well-being of A&E users. I don't think that slide's loading, but anyways. And then, so just to give you an idea, through the course, I learned engineering softwares like SolidWorks and Autodesk, as well as a lot of the Adobe Design Suite. And these softwares I still use frequently today in my engineering job. And kind of extracurricular things I did was, during university, I was part of a group that 3D printed and manufactured a prosthetic hand for a young boy in Glasgow. And it was during this project I realised the huge positive impact that engineering technology, like a low-cost 3D printer, can have on someone's life. And if the video plays, you can see Ryan's 3D printed prosthetic in action. And following on from this, I was president of the Female Engineering Society, so I was responsible for a committee of over 100 members, so a bit smaller than the IMechE member list. But what we did was we organised school outreach visits that focused on inspiring youth, in particular females, into STEM. And throughout my summers at university, I've worked in various places around the world. So in India, I helped restore the water supply to a small rural village. And it was kind of after this summer, I came back to university with a new perspective on what I could actually use my engineering degree for. The next summer, I then worked building robotic beer taps out in Turkey. And then in my final summer of university, I worked out in China at IMechE Toledo, and both of these internships really shaped what type of engineer I am today. I was able to experience working in a really small startup versus a massive international company, which guided me to when I was applying to jobs after graduating from engineering. So, on to what is my job now? Well, at Cool Mill, we effectively sand rice. So, kind of like what Abby was saying was, have you ever really thought before you sit down to eat a meal or buy food at the supermarket, the journey that your food has been on from farm to fork? Or more importantly, what type of machinery has been used to get it looking and tasting the way that you are used to? Well, the honest answer to that question is I had not thought about this at all before I started working for Cool Mill. So what do we actually do at Cool Mill? So we take the raw paddy, which is grown in the fields and is worth very little to the farmer, and we process it into white rice, which is a high value commodity, and that can be sold and packaged on the market, and it can also be exported as well internationally for a premium price. So we at Cool Mill, we've created a modern, ultra low power, simplified and sustainable approach to cereal milling. Many people live daily with food and fuel poverty, and for 3.3 billion people, rice is life. Traditional rice milling is very wasteful and it's really power hungry, and that's something that's very different with the Cool Mill machinery, is that we can run off grid, so we can be attached to solar power, and because it's low power, it means that we save money also for the rice processors and the farmers who are using the machinery. We're also doing a lot of research into how we use the whole rice plant. So the waste byproducts that are from the process, we're looking into ways that we can make into, so we're making the bran into a nutritious human food ingredient, and also using the husk, so that's kind of the skin that you can see in the raw paddy, we're using on how we can use that for power as well. So it's very much focused on circular economy, and we don't want to waste anything in the process of milling the rice. So in my day-to-day role as a project engineer, I do lots of different things, from testing and carrying out milling trials in Sheffield, which is what you can see in the pictures there. And this can involve counting and grading rice. And then also, I was a project manager on one of the projects, so I had to organise the team and manage the finances for a 9-month project, which was a totally new experience for me. But my experience at university as the president of FemEng and like working and volunteer really helped me in my role today. So during the pandemic, I also worked on an augmented reality project that you can see in the bottom right there, where we used the HoloLens to be able to remotely service and maintain the Cool Mill machine. So for example, if I was at the machine in Sheffield and I was unsure on how to fix something, I could call our engineer in India, IMechE, and he could draw on his laptop and guide me to show in real time the parts that I needed to fix. And this is a kind of huge step in it's a massive leap in where manufacturing is going to be going. And it's something that Cool Mill and I have been involved in, is making our machine be able to run lights out and remotely, which is the future of manufacturing. And as the project manager for the husking project, I spent some time grading rice. So that's where we look at the number of brokens versus the head rice. I've also just been really fascinated in my job about all the different factors that are at play when you're processing rice. So trying to find that sweet spot between the speed of the machine versus the capacity versus the quality of the rice that's produced at the end, and then being able to analyze these results for our customers is a huge part of my job, and it's something that I enjoy as it's exciting, but also it's not on my laptop. I'm able to actually be in the unit, round the machine, and kind of using my hands, which I love to do. And I really chose to enter this industry because I recognize the positive impact and potentially life-changing effects that technology can have on people. I never knew much about the food and drink sector before, but from working in India and China, I'd really observed how the different cultures and countries process, sell and eat rice. And we're very fortunate in the UK to either import food that's already been processed and packaged in country, or we use our own advanced food and drink processing systems in the UK. I think the question that we should all be asking ourselves, and kind of a food for thought as the innovators of tomorrow, is how can we make our globally secure food systems that are sustainable and help reduce poverty? So during the past year, we've seen with COVID and Brexit how vulnerable our food systems are, and relying on imported food exposes our country to really a limited supply. So one of the kind of main motivators and challenges for me as a project engineer at Coolmill is thinking about the rice. So rice is a major polluter, and thinking about how can we reduce that. So by being able to process rice better and being able to reduce the wasted rice, we can really contribute towards the planet better. Because if we continue to just grow more rice, it's not really an option because so much land is being used already. So yeah, these problems of climate change, we have a growing population and our insecure food systems, these are applicable across more than just the rice industry. And I really believe that these exist as an opportunity for us to look at solving as engineers. And one thing that really resonates with me is I'm actually going out to Nigeria in a couple of weeks to talk to farmers and rice processors. And this is something that when I'm maybe having a bad day, I just think of these people who are smallholders and growing rice or processing it, and the little value they're getting because they have a lack of access to better machinery. And it really does remind me why my job is important, and also it really motivates me to work harder and to figure out how we can get this best-in-class rice processing machinery to the people who actually need it most, and how we can make it affordable and accessible to them. So that's something that really gets me out of bed in the morning. So yeah, open to any questions, and thank you for listening.
Thanks a lot, Penny. That was great. Just a reminder to all the attendees, if you can use that Ask a Question box. I think it's called Ask a Question. But yeah, type any questions you have in. It'll pop up here and I'll direct them to the relevant speaker. I'll give you a few minutes to do that. In the meantime, Rob, is it all right if I ask you about that wind-powered aerator? That looked pretty interesting. Is there any redundancy backup in case the wind is a little low one day?
Yeah, definitely. I mean, there's backup compressors in the picture. There's a green kiosk with a pipe coming out of it. That was the backup compressor. But yeah, when the wind's blowing, yeah, the aerators are out there, and I think they're on pulley systems that out in the middle of the lagoons there. So
that's
the
fantastic.
pontoons.
It's great to see these green initiatives come through with real world applications.
Yeah, definitely.
Yeah. Still looks like we have no questions. Give it another minute.
Yeah, on that particular site, it's Pamela here. It's over in it's a Yorkshire water site. It is actually the largest in the UK now, so it's one that we're all keenly watching to see how it performs. Yes, it's quite interesting. Before then, we just had a couple in Scottish Water, I believe, but much smaller.
Wow. Is it directly coupled then? For example, if the wind picks up, would it aerate more?
I suppose in theory it could do. Sorry, I'm not involved that much into the detail of it, but there'll be a brake on it, so you won't lift them off. So there'll be a brake. They will be limited. And then likewise, when it's low wind, you've got the backup of the compressors to just add some extra aeration into there to keep the treatment going.
Okay. Oh, that's fantastic. Let's see. Right. Well, looks like we don't have much else. I'll end it there. Thanks a lot for your. Yeah, it is. I'll actually, before I do that, I might go to the next slide.
Wait, there's some questions in the chat.
Have we got some?
Can you see them?
Yeah. So have we considered solar thermal desalination in the water treatment process? What are your thoughts on this? That's interesting. So I'll direct that perhaps over to Pam or Robert. If you've been involved in desalination, have we seen any solar thermal plants?
I personally haven't. No, desalination generally tends to be in the warmer countries, and that's where the plants are over in Qatar and the like. Solar as well. Sure, it has been considered, but I'm not being involved. It certainly makes sense because you get a lot of sun over there, so it makes sense to try and offset some of the electricity that you need to use to power your desalination with some solar.
Yeah. Oh. Got another one here for Penny, I believe. Penny, is it possible to use a rice mill in remote areas?
Yes, so this is something that we are working on right now, and is the reason that we're going out to Nigeria is the machine that you saw in the presentation that I showed you. That's kind of a larger commercial machine. But what we can do and what I've been working on is we've been making a very small 3D printed rice mill. So it would just sit on a desk, and we're doing this so that we can reach those people in really remote areas, and that the farmers can process their rice when it comes off the field, and they have their white rice ready to sell themselves. So it's really this aspect of using engineering technology to empower the people at point of source. And it means that rather than them paying someone to transport their rice to this really, really big mill, which is miles away, they can then sell it themselves at a premium. So yeah, we're definitely planning to disrupt the rice value chain by doing this. So we are really trying to do a lot more market research first, because we don't want to put any women who are actually the 80% people who farm and process the rice. We don't want to put them in danger. So there's a lot of, it's not just a technology aspect we have to think of. We've got to think of the social and economic implications as well of bringing a disruptive technology into a rural village.
Oh, of course. So is it predominantly in terms of utilities required for this? Is it mainly electricity? Is there maybe heavy consumption of water or nitrogen or anything else that's required?
Yeah, so a lot of water is used to grow the rice, which is one of the reasons why processing it is so important. But the really good thing with the cool mill machinery, and something that last week we had calls with maybe over 5 mini grid providers in Africa, is there's a lot of mini grids or solar systems that have been put in, and the communities they've been put can't afford to pay for the electricity, just as we can't now in the UK. So there's a huge drive of productive use of electricity, aka being able to put a machine which can make the money, like a rice mill, onto being able to attach onto the electricity grid. But the problem we have right now is any off-the-shelf milling machinery, it uses way too much power because of the way that it works. So we've kind of unlocked this whole new market that we're really excited about. And it's much better than the diesel jet parallel, really old machinery, which is currently being used in these old villages, which just smash the rice to pieces and make it nowhere near as valuable if they had a better machine to process it.
Wow. Oh, that's great. Thanks a lot. I've got one last question. I'll open up to everyone, all the speakers. But how do you feel that your industry is changing in recent times? Have you any examples perhaps you could share? I think sustainability would be a key note, but anything else would be of interest as well.
I think everything's becoming more integrated now. I mean, before we mechanical engineers and civils were civils, and so there was a lot more silo thinking. But I think nowadays you got to work, be able to work with a lot more integration with other teams, and you've kind of as mechanical engineers and electrical engineers and so forth, you've got to be a bit more aware of all the other disciplines. And now added on top of that, you've got things like digital twins, the digital environment, BIM, and all this kind of all these modern technologies and augmented realities and stuff like that. You've got to be able to take on board the way the industry shifts towards digital and be able to utilize that in your sectors and your work.
Of course, yeah.
Yeah. And I think in the food industry, there's a lot of changing responses to different trends. Obviously, the pandemic changed the way people eat and their eating habits. So we're always kind of keeping up with what people are wanting. If that's more plant-based solutions, obviously there's a whole technology field that then has to be created to kind of keep up. And how do you make meatless items taste more like meat, make sure that fiber, that flavor, and all those different things are kind of keeping up with the demand of customers.
Oh, of course, yeah. So would you say there's a lot of R&D perhaps in the food industry? Would you say that there's new developments, as you say, to keep up with consumers' demands?
Yeah, absolutely. No, and R&D is one of the most exciting elements to kind of see where those new trends are coming up as well.
Yeah. No, it's fantastic. Cool. Well, I'll end it there for now. Thanks a lot for your time. I believe Murat Islam's email is on the screen, so if you'd like your CPD certificate, please email Murat on there and we'll get them done. And I believe there's a feedback link as well. If you could click that and give your feedback as to what you thought of this webinar, that'd be lovely. Any closing thoughts from anyone else?
I think there's I think there was a couple of questions that we didn't get time to answer around, but if we can make a note of those, and we'll be able to give some feedback, answer those offline afterwards.
Yeah, sure. All right. Well, thanks all. We'll end now. And yeah, see you at the next webinar.
Thanks very much, everyone.
Bye.
Cheers.